Hi, this is Robert Quimby. I'm going to give you a quick guide for getting started with Python. So in this tutorial, first thing we're going to do is we're going to just talk a little bit about the development, the history of Python, how it came about. It's important to how it's being used. And we're going to do some quick tests. We're going to show how you can actually launch the Python interpreter, and you can do some calculations, some basic kind of calculator level calculations. We're going to go over the basic types of data in Python, and then we're going to do some of the basic flow control statements, test those out, and show you how they work. So just right off the bat, for those of you that don't know Python, I wanted to give you a little introduction here. So this is Python.
Monty Python's Flying Circus.
All right, so for those of you who are just utterly confused by what's going on here, Python actually comes from Monty Python, and that is a comedy sketch group out of England from a long time ago. But it's very popular in some of the more choice circles, especially when you get a bunch of engineers or computer scientists around, or scientists in general. So that's where the name actually comes from, although if you look at any of the documentation that's up these days, you'll see just a bunch of snakes, because people have no sense of history. But I want you to, and I want you to know where this programming language came from. It came from this gentleman right here, whose name is Vito Gwen Rossum. And there's a lot I like about Guido. I just want to show you his Wikipedia page here. So the cool things about Guido, first of all, his name is Guido. That's points in my book. Second of all, he was born in Haarlem. Not the Harlem in New York, but Netherlands, but it's Haarlem nonetheless. And the third thing is, of course, actually the third thing, he seems to enjoy beer, and I give him points for that as well. But most importantly is he developed this Python programming language. And he didn't do this because somebody told him to, or because he had to for his work. He did it because it's fun. And he just looked at what was available in the world, all the different computer languages, and there's a lot. There's C and Fortran and Perl and all these different languages, and he said, we can do better than that. And so we just for fun sat down and saw if he could come up with something better, and I believe he did, and a lot of people might support me on that. He came through with this language, and the most incredible thing is after he put all this time into it and figured out how to construct it, he basically gave it away for free. This is something that's out in the public. He doesn't control it. He certainly is a leader in the Python field, but it's taken on its own life, and anyone now can contribute to this program, to this package, and make the world a better place. So there's some basic concepts that are integral to Python. That this is Guido's way of correcting mistakes that have been made in other languages. So he wanted to make things that are easier to read. Why not use more natural syntax, for example? He wanted it to be enforced, so he wrote the rules for the programming language such that you essentially have to write good code. And that's kind of been adopted by the community. People who write in Python go out of their way to write code that's not only functional, but that is it looks good and you can read it. It's actually something that you can share with somebody else and they can understand what you've done. That's an important part of the language. All right. So, of course, I'm just going to give you a quick introduction here, just talk about a few things in Python. It's a huge programming language, and there is a lot of documentation online for it. And that's actually one of the great things about Python, is that because it is this community-driven language, it's not something that somebody owns. There's documentation just everywhere, and it's pretty good documentation too. The first thing that you should start with is the Python tutorial. This is from python.org. You can go there. We're going to use version 3, and there's a nice tutorial here, and it has a lot of information in it about everything you'd ever wanted to know. I'm not kidding. There's a lot in there. A lot of stuff everything you want to know about this language. So I do highly recommend, and you really should seriously do, is sit down and read through as much of this as you can. Um, this is how you learn, right? This is a great way to do it. There's lots of examples in here. There's things where they show you little blocks of code, and what you should do is you should sit down and you should pull up your own terminal and you should type these things in, and you can see what happens, and you should play with it. You should change it around. Don't do exactly what's in the examples, but see what happens if you change things around. Don't do 2 plus 2, do 3 plus 3, whatever. Just see if you can understand it. That'll help you learn this language. All right. And on top of that, there is this style guide. So if you're kind of curious about how to do these best practices, how to make code that is readable for other people, and how to conform to the standards that other people have used, there's a documentation here about. They'll tell you everything about how many spaces should I indent each line of code, and how should I comment things, and everything you'd ever want to know is in here. So this is the resource. It's called PEP8, and it is the source for Python style. Okay. All right, so the first thing that you do when you're learning Python is that you use it basically as a calculator. Now you have 3 choices for doing this. First thing you can do is you can pull up a terminal and you can start Python. And the way you do that is just typing Python. This is a Unix command line. Type Python, I hit enter, and there it is. We're now running Python. You can see I'm running Python 3.5. Make sure you're running Python 3. If not, you got to start and start again. Stop and start again. This is one way to do it. You can exit this. I hit Control D to exit. You can type exit. You can also use what's called the interactive Python. This is IPython. This is what I think you should use more often if you're going to be doing a command line approach. You can see right away that there's this nice little color highlighting here. It's waiting for input. It says that's input 1. And you can type things in here, and it'll learn things, and it'll tell you what you have, and it'll tell you the output. When you have some output from a line, it'll print it like that. So this is much better if you're actually in an interactive mode where you're typing in code and testing things out, doing things by hand. This is the environment that you will often use. I'm going to exit this, however, because there's a third option, which is you can use your Jupyter Notebook. And if you're viewing this, you're looking at a Jupyter Notebook, and you should have access to the actual notebook itself. And I highly encourage you to actually play along now, to actually pull up a window with your own Jupyter Notebook in it and start typing in as we go along here. So let's just do some of the basic things that you do when you use Python as a calculator. The first thing to note is that you can type in some value. You can run this. I'm going to run this south, Control Enter. And I hit that, and it's going to evaluate whatever you type in, and it's going to figure out the value and return that value. So you can do math here. You can do 4 plus 4 if you want, and you can run that cell, and it'll give you the output here. The output is 8. All right? All right, so that's the first thing you can do. Of course, there's other functions. You can, instead of adding, you can divide. 4 divided by 3. Notice that you got a floating point number. I did it. You got a decimal here. If you ran this code and you got the answer 1, you're probably using Python 2, because they used to use a different division rule. They used to use inner division, which you can use with 2 slashes here, which gives you just the integer value from that division. And when you're working in a calculator mode, you can follow kind of the standard math grouping rules. So if you want to put a number inside of parentheses and then add something to it, and then maybe multiply something by that number, and then take this whole thing and divide it by something else, you can do that. And make sure you understand the precedence here. So what's happening is it's you have 2 by yourself, and then inside the parentheses, it's going to evaluate that expression. And then first it's going to do the multiplication, and then it's going to add 2 to that. So that's where we're getting our 15 plus 2 divided by 2 is 8.5. Okay. So these are just basic, we're just using it as a calculator now. We're not doing anything too exciting. a calculator works just as well. But there are, of course, many more things you can do with Python that give you some strong advantages over your typical handheld calculator. One of these things is assignments. We can assign a value to a variable. So x here is going to be a variable. So it's the name of the variable. And on this side of the equal sign is the assignment operator. So we have the name of a variable, the assignment operator, and then this side, the right-hand side of the equation here, is going to be the expression that is going to be evaluated and then assigned to the variable named x. All right, now this is an important concept. So what happens when we do something? We can do maybe 4 plus 3. When I hit Control Enter and it runs this command, okay, we just ran this command. What happened was first it evaluated 4 plus 3. That's 7. Right? It takes 7 and it says we're going to assign that to this variable named x. So that means it's going to save this value 7. This is what this evaluates, what this expression evaluates to. It's going to save that to the memory. So somewhere in the memory, we're going to basically change the voltages inside to represent this number 7. Okay? Now, there's more to it than that. So the number 7 goes and stores in the memory. Then the second thing happens is that we have a reference to that part of the memory. We have to know where we stored it in the memory. All right? And then on top of that, we have to know that when I type x, again, that it's supposed to look at that part of the memory and pull out the number that we have, or whatever expression we have saved into the memory, and retrieve that. Right? So x is going to be equivalent to 4 plus 3, which is 7. So I can use these two now interchangeably, 7 or x. Right? But the key thing is, again, x is a variable. So I can name this whatever I want. I can name this a or t or whatever I want to do that. And that's going to save this expression into another part of the memory. It's not going to redefine x. X is still going to be 7, right? But now a is also going to be 7. All right? So this is an important concept. We have assignment here where you have some part of the memory and you have not just a value in that memory, but then you have this reference to where that is in the memory. And we are calling that, just at our level, we're going to call that x, or we're going to call it a, or we're going to call it Tuesday, whatever we want to call that variable, just so that we can reference the value that that's been evaluated. All right. So there are several basic data types that you can work with in Python. We've already been working with integers, things like 3 or 4, 6 or 8. Those are all integers. We can have floating point numbers like we saw, just 3 and then you add a decimal point, and that's a floating point number. So that's 3. You can make 3.0 as many zeros as you want, or you can add other numbers. That's a floating point number. Okay? And the third thing we do is we can make a string. A string can be a single character, like C if we wanted, or it could be a word if we want it to be that. In Python, there's no difference between those. There's not a separate class for characters and for strings. They're all just strings. Okay. Now there's actually different ways you can define a string. You can use single quotes, you can use double quotes, you can use triple quotes, you can use double triple quotes. All these are going to be interpreted as a string. There's some advantages why you would want to do one or the other, but they all end up being strings. When you've defined a string, you can actually take what's called a slice of the string. That means just take part of it. So we can define this value a equals that, and we can see that it's defined to be this string here, and it shows the quotes here, right? Because this is not an integer here. This is a string. It's a different data type in Python. It's not the same thing. Let's say I just want the first part of this. I can say, give me a of 0 to 4, for example, and it'll just give me the first 4 values in that string. So we're using these square brackets here. Notice we're using square brackets. And we're giving indices here. We're saying start at 0. This colon here says we're going to go from 0 to somewhere else, and 4 is going to be where we're going to end up. Now, do be careful on how you do this, because you may notice the number 4 is not written out here. It's just the first 4 values. So Python is a zero index language. That means the first element in an array is the 0th element. So be careful about that. And when you do this slice structure here, and you have something colon something, that second value is going to be where the slice ends. So it's not going to be included in the slice. So the way you can think about this is you can think about the letters or the characters in a string as being in different cells. And you can think about indices being on the left side of that cell, 0, 1, 2, 3, 4, 5, 6. So if I ask for I have the string Python and I ask for indices from 0 to 4, it's going to cut off right here. And I'm just going to get the pyth. So we can see that actually. Let me do pyth Python. And I could actually define this to be some string like this, and then I could work with it. But you don't have to, because if I have s equals Python like this, it's the same thing as Python. So I can just work with this. And I can put a square bracket after that, and it'll understand it. And I can say, give me the elements that go from 0 to 4. And as promised, pyth is the output. Okay? Another thing you can do is you can actually use negative indices. These start counting from the last value is -1, then -2, 3, 4, 5, all the way like that. So if you just want, say, the last element, the last value in this string, you can just ask for a -1, and it'll start at -1 and give you everything else in that list, in that string, I should say. And there it is. That's n. It just gives you the n. And you could, of course, do -2 if you wanted the last 2 values. That gives you the second to last value. If you want everything else, then you need that colon there. That's what that does. It says, give me start at -2 and then keep going. And I could write a value here, but if I just run like that, it'll give me everything else that's left in the string starting with -2 right here. Okay? So this is again called slicing, taking slices of a string. All right, so we can move on to some more advanced data structures now. So we can take those individual data types and we can put them together into lists, tuples, or dictionaries. Lists are defined using square brackets like that. And so I can put things in a list and build up a list like that. They're separated by commas. The spaces are not important. I can do it like this or like that. Doesn't matter. Tuples are the same, are very similar. They're actually a little bit different, but very, very similar to lists, except they start with parentheses instead of square brackets, like that. And dictionaries, this is a different type of a data structure entirely. This are things that are put in curly brackets, and you have two values. You have a value which is the key, and then you have a value which is the value corresponding to that key. So I'll show you that actually in just a second. But let's start actually with lists. So here we go again. We have square brackets here, and we have comma-separated values. We have 4 values in this list, and I'm going to define that to be A. And I want to point out that you can put in any type of object into a list. They don't have to all be integers or all be floating points or all be whatever. You can put in an integer and then a string, and then this is actually a function. You can put a function in there. Everything in Python, as we'll see in a second, is an object, and you can hold any type of object in a list. So I can just run this here, and you see it's perfectly happy with defining either one of those lists. We can index these lists in a very similar manner to what we just saw with strings. So we just defined this array B, which has these 3 elements in it. And if I want to take the first element of that, I can use 0. And that'll just give me the first element there. I can also do, I can take a slice. So I can go from 0 to 3, and that'll give me the first 3 elements, just like that. Right? On top of this, what we can do, one thing we can do with lists is we can reassign the values in there. So that first value is 1, right? This is equal to 1. I can reassign it. I can use my assignment operator, and when this runs, it's going to change the value and the first element of B to, let's say, 4. So I can run that, and then if I run this again to see what those first 3 elements are, see it changed. The first element changed to 4. All right, that's just what we did. So tuples, like I said, are very similar to lists. We can define a tuple T with parentheses, 1, 2, 3, and we can set that in. Now the key difference between tuples and lists is that tuples are immutable, right? Immutable. What that means is you can't change the values inside them once you've defined it. So I can ask what is T of 0, and it'll tell me. It's 1. But if I want to assign that, if I try to assign T of 0 to a new value, if I try to do this, it'll complain. It'll say, no. This is a tuple, and that does not support item assignment. You can't change the value of it after you've defined it. Now, that just means, I want to go back to this idea of assignment. So in here, we assigned this tuple here to this variable T. Right? So T is pointing now, it's referencing some part of the memory, and when we do this command here, we're trying to change the values in the memory, and it's saying we can't change those values in the memory. But what we could do is if we wanted to define T to be differently, we could just redefine T entirely. We could say 4, 5, 6 if we want to do that, and this is perfectly valid. Right? Because we're not actually changing where we put these values in the memory. We haven't changed anything there. What we've done is we've said, with this operation, we've said, let's define a new variable T, all right? A new variable, we're going to call it T, and it's going to reference this tuple in the memory, okay? So we're completely redefining T, right? We're not changing the values in a tuple that already exists somewhere in memory. We're creating a new tuple, and then we're going to create a new variable T that's going to reference that. And once we've done this old tuple that we had in the memory, that's now lost. All right, so Python does automatic garbage collection. It figures out that there's no reference to that value anymore, and it deletes it from the memory automatically. You don't have to worry about garbage collection or anything. It's just gone automatically. Okay. All right, so the other data structure we're going to talk about is dictionaries. The way you define a dictionary is with curly brackets. So we're going to define a dictionary D. This is the name of the variable. And dictionary is defined here to start. It's going to be an empty dictionary to start, and then we're going to build it up. This is kind of the easiest way to build a dictionary. So we start with an empty dictionary, and then we're going to add elements to it. And the way you do this is you define a key. In this case, it's going to be the string called supernova. And we use square brackets. Right? We reference the element of the dictionary that we're going to call supernova, and the value that it's going to point to is an exploding star. And we can do this we can add other definitions. So the definition of a planet, we can make a rock, we can define a red giant, we can set all this up, and then if we want to access the value, we just say what is D of supernova. We run that. It tells you an exploding star. And you can put in anything here and it'll tell you the value of it. So go ahead and try that out. All right, so as I've alluded to already, everything in Python, everything is an object. All right? And that's why we can do this magic of putting different data types into the same list, is because they're all objects as far as Python is concerned. So when we define something like a string, so this is a string here. I'm calling it sentence. That's just the name I'm going to use to refer to this, this string, which is going to be stored in the memory. We define this. I can run that and do it. So now we have a variable called sentence, which is representing this object here. But this object here, when it's evaluated by the Python interpreter, it's evaluated and it's turned into an object. So we're not just storing simply each one of these characters in the memory. There's more information that's being stored when we create this object here, right? and that includes methods, which are tools that you can use to manipulate the data. So this is the data that's stored. All those characters are stored somewhere in the memory, and the object that we get when we define this object right here, that comes with tools that we can use to manipulate that data. So one of the things we can do, for example, is we can take our sentence and we can split it. There's a method that comes with this called split, and what that'll do by default is it'll look for all the white spaces, and it'll take our string and actually turn it into a list. So I can show you this. If I run this, so this is the output here. The output is a list with 1, 2, 3, 4, 5, 6 different strings in it. Each one of those are separated by where we had these blank spaces before. So really, everything in Python is an object, and I can demonstrate this by taking something like 15.7. All right, that just looks like some floating point number. You run it, you get a floating point out. It doesn't seem like it's very exciting, but if I put parentheses around it, I'm only doing this because the Python interpreter would get confused if I put a dot here, and you need it to put a dot to call a method. So first I'm enclosing it in parentheses, then I'm going to put the dot here. Right? And then I'm going to call a method, because this floating point number, just when we define it like that, has actually a few methods. One of them is called hex, which will convert that into a hexadecimal number, and there it is. So everything in Python is an object. There is great help built into Python. Of course, Google is fantastic. There's a lot of things you can check online. There's a lot of help sites out there, and if you have some issue, there's a high probability that someone else has had that same problem already, and they've asked one of these boards, maybe Stack Exchange, for the solution, and it's out there. So that's a great way to get help. But there's also help built right into Python. This is one of those, coming from the design philosophy of making something that is easy to use. There's help built right in. Right? So you can run help. I'm not going to do it like this. I'm actually going to help 15.7. Remember that variable? Well, let's see what help says about this. So I run that. It turns out that that number there is a floating object. Remember, it's an object. And it has all these methods. Here's all the methods that are defined. And one of those, if you scroll all the way down here, is hex. That's the one that we ran on there. There's all these other methods that have these double underscores trailing and leading. Those are methods that are perfectly valid and things that you can run, but there's a kind of a convention that if somebody puts a double, somebody's making code and they design a method that has double underscores, it's something that a typical user would not use. It's designed for internal use or for doing special tricks. So you're probably not ever going to use these methods, but they're there, and you can run them just like any other method. There's nothing private. There's no private data types or private methods or private functions in Python. It's all out there. Okay, so we've seen how to define some different data types and how to run Python as a calculator, but eventually you're going to start wanting to do some coding. So we're going to take the first steps here. We're not going to write much. We're not going to write any procedures or any functions right now. We're going to start with the basic elements of coding, which are conditional statements. So sometimes you want to do one thing and sometimes you want to do another, and it might depend on some third parameter. So we need to have some structure of doing something or doing something else. And the way we do that is with an if statement. So we can create an if statement. So I'll type if, and you see it displays in green because it knows that's a special word in Python. And then we can put any expression we want. So we can put the expression x equals 4, for example, right? So we could put that in parentheses if we wanted to, just to enclose it and make it clear, but it's not actually required in this case. You can put any expression here, anything at all. You can just put the number 5. That's an expression. X equals 4 is probably a more traditional way to start. And then you put this colon here. And that colon says that we're about to change into a block. All right, so when you look when I hit return, the cursor is automatically indented because it's waiting for me to insert a new block of code. And what's going to happen is when we run this cell, if this evaluates to true, and that's a data type in Python, capital T for true or capital F false. Those are Boolean data types. If this evaluates to the Boolean to true, or I should more specifically, if it's not false, then it's going to run this code block here. So we could do something like print. We can use this function print. Print I'm so happy if x equals 4. So we can run this, and apparently x is not 4. That's too bad. So let's give it something else to do. If x is not 4, then we'll do something else. If it's not 4, so we say if x equals 4, else, and this will take any other result. If this first line here is not executed, now we're going to execute this block of code. We use the single quotes and double quotes. You gotta be careful about those. And now we can run it. And we can see that x was not equal to 4. We defined it earlier. What did it end up being? Let's see. X is actually equal to 7. That's right. So x is 7. So this block of code is not evaluated, but this block of code is. So this is a conditional statement. We can actually add a third condition. We can say elif, right? That's else if x equals, let's say x greater than 4. If x is greater than, print x. We'll just print what it is. If we run this now, you see it gets to this line, it executes this line, it says x is not 4, so it skips this block. It says, we'll run this elif block. If x is greater than 4, then and that's true, so it runs this block, and then it doesn't run this last block. That's short-circuited, and we don't run the rest of the else statement. Okay, so that's basic conditional control. And one last thing that I'll put in this introductory tutorial is some basic looping. So this is something that's very convenient to do. Sometimes you want to do things many times, or you want to do them many times but in slightly different. You want to do a slightly different thing each time, and that's where you want to use a for loop. So the way you compose a for loop in Python is slightly different than other languages, and it's actually, it might take a little bit of getting used to if you're used to C or Fortran or something like that. But once you do, I think you'll really like this. The way you do it is you start by typing for. It's a special word. It turns green on my screen. And then we're going to have the variable that we're going to loop over. We're just going to give whatever name we want to use for our loop variable. I'm going to call this, you can call it x, you can call it 3, THRE, like that. I'm going to call it word, just any valid variable name. For word, and then you say in, type in, that's another special word. And then you give it something that has a sequence of values. So I can give it a list. That's why I typed a square brackets. And I'm going to put eggs, bacon, and spam in this list. Okay. Again, I'm going to use the colon here to say that following this statement is going to be a new block of code that will be executed. And so every time, what's going to happen here is we're going to take this list, and for each one of the elements, each item in this sequence, it's going to assign the value one by one. The first value here is going to be assigned to word, and then it's going to run this block of code. Then it's going to come back to the top. It's going to assign bacon to word and run the code again, spam to word, and run it again, and then it'll stop. So each time it runs here, what I want it to do is just to print, and I'm going to have it print spam and whatever the word is. Print spam and word. And if I run this, you can see what we get. So again, it runs, the first time it runs through, this variable word is assigned eggs, and it prints spam and eggs. Next time it's bacon, spam and bacon, spam and spam. Right? So that's a for loop. A really cool thing that you can do in Python, and I want to just introduce you right off the top, is list comprehension. So that statement, you saw I had a couple lines there to define that. You can actually put all that onto a single line, and we're going to do that. What I'm going to do is I'm going to put a for loop basically inside of a list, and it's going to run through and run the for loop just like we did before. So I'm going to, what I want to do is I want to print. That's how you start this list comprehension. You start by saying what you want to do. You want to print spam and whatever the word is, spam and word. You're going to do that for word, that's your variable, in, and then you need your list, where eggs, bacon, and spam. Okay? So here's what's going to happen. This is actually the same thing we just did before. I'll run it here. And look at that. It gives the same stuff here. And actually there's some extra output. I'll tell you about that in a second. But just look how this is. This is actually written in a way that you can just read it. It says print spam and word for word in eggs, bacon, and spam. Right? And that's coding. That is this is not just a good way to write. This is probably the best way to write this particular for loop in Python. So look out for this. This is really a cool thing that you can do. Now, one thing we saw here is that the output actually is this list with 3 values in it. Each one of those is none. Because what's happening is we're actually creating a list here. And in this case, the value is the value that's returned by this statement here, and that's none. That's why they're getting these nuns. None is a reserved word in Python, and it signifies none. It signifies there was no output. If I want to just suppress this, I can actually just do that very easily by putting a semicolon at the end here. And all that's going to do is just going to hide this output here so we don't have to see it. All right. Another thing I can do, and I can do this either way. Maybe I'll combine what we did a second ago. So remember this example, just a regular for loop, the standard way to do it. Maybe I don't want to print out every word. I just want to print out the short words. So I'm going to use a conditional statement here. Use that if. And I'm going to use a function called len, L-E-N, which computes the length of an object. And I'm going to compute the length of whatever word we happen to be working with. And if that length is, let's say, less than 6, then I will print this out. Otherwise, I'm not going to do anything. So I can run this again. You can see what happens. Bacon is longer than 6. Actually, is equal to 6, so it's not less than 6. So it skips that line. But it runs the for loop runs for each one of these words. It evaluates this expression and prints only if this statement is true. We can do the same thing in list comprehension. We just have to add it to the end here. If length word less than 6. And if I run this again, it figures that out and removes bacon. By the way, in Python, when you have a list like this, you can put in breaks, in line breaks like that, and it'll work just fine because it knows that this bracket here closes that. So you can hit enter and it'll be fine. All right, so one last thing. A lot of people are not used to this style. This is in many languages called a for each loop, and they want a traditional for loop in a traditional language. You can simulate that in Python using a function called range. So if you want to do kind of your standard for I equals 1 to 6 kind of loop, you can do that. You can say for I in range, look at that, it's green because it's a special word, range 6, and then you type the block of what you want it to do, print, let's print spam again, print spam, and I'll just put this all in one line. You can do that using this keyword end, which I'll tell you about maybe in another demo. But if you run this, it'll print spam 6 times like that. So you can simulate this, but I highly recommend that you actually go back and use this style, this for each kind of style of for looping, because it's really usually what you want to do. Usually you don't care about that index variable I. Usually you care about each one of these things. All right, so that's it for this one, and good luck.